In this TechCorner video, we are going to explore the mysteries of the inverse square law. As a photographer, I'm sure you've heard the inverse square law at some point, but do you know what it is? Many photographers have no idea how the inverse square law works. Just as many assume that it has something to do with flash photography, and since they don't use flash, they don't need to know about it. The truth is, if you use any kind of light in your photography, which by definition should be all of you, then you need to understand the inverse square law. Now, in general, anything known as a law is important and you should have a good understanding of it. I'm not going to go into the complex maths in this video, however, this formula is the basis of how this formula works. At first, this may seem quite hard and complex, but keep watching to the end and I promise it will all make sense and be quite easy to understand. So let's start with the definition and break it down from there. The intensity of light is the inverse of the distance squared. Now don't worry, I'm about to explain this in plain English. To start with, just like stops of light, distance is a relative value based on your initial distance from the light source to your subject. Note that I use the term light source, which can be a window, a reflector, a constant light, or a strobe. Anything that is illuminating your subject is a light source, regardless whether it is natural light or flash. So let's start with a simple setup where we have a model and our light. Now don't worry about the units of measure for distance as it is relative. It makes no difference if you are working in meters, centimeters, feet, inches, or any other scale. As long as you don't change the units of measure, this formula works. So in this diagram, we have the light 1 unit of measure away from the model. Putting this into our formula, distance of 1 unit squared is 1. Inversing it makes it 1 over 1, which is 1. So this is our metered correct exposure. If we move the model double the distance from the light, she is now 2 units away from where we metered the light. So 2 squared is 4. Inverse that and you get a quarter. So by moving the model to double the distance from the light, our intensity dropped not by half but by 75%, or 2 stops. If we keep increasing the distance by the same 1 unit of distance, you quickly see that the drop in light intensity is huge in the first step, but then plateaus quickly. We lose 94% of the light in the first 4 steps, but only 5% over the next 6 steps. Now I hear you asking, that's great, but why exactly do we care about this? Well, I'm glad you asked. Let's say you're taking a portrait of someone, and for whatever reason you have to put the light 2 feet away, or 60 centimeters for our metric friends. The reason why the light is 2 feet away is irrelevant here, but I assume you had good reason to set it up that way. Now, if your model moves 1 foot, or 30 centimeters, towards the light as they are posing, you will end up with 2 stops overexposed. If your model moves 1 foot away from the light, you will end up 2 stops underexposed. So if you need to have the light that close, you need your model to be preferably sitting still and not moving. 1 foot of movement either way is not a lot of movement for a model posing, but for you, the difference in exposure is huge. So if you know your model is going to be moving, you need to set up your lights further back. Obviously, moving the light further away has an effect on the quality of light, but that's a topic for another video. The other reason we care about the inverse square law is when we are trying to control the background. Technically, you can make any background completely black, even without a backdrop. But for this to work, you need to use strobes as you need to eliminate ambient light from your photo. So looking again at our diagram, if we have the model standing in front of a wall the same distance as she is to the light, the wall will be illuminated with 25% of the light from the flash. Although that's quite dark, it still makes the wall clearly visible in the image. So we have 2 options. We can bring the light closer to the model or move the model and light further away from the wall. Since we know from the previous example that moving the light closer will restrict our model's movement, we decide to move the model and light further away from the wall. How far we need to move will depend on a range of factors, including what color the wall is painted. If the wall is a dark shade of color or gray, its ability to reflect light back will be greatly reduced compared to a white wall. Now let's assume that the wall is a neutral gray in color. Technically, if we move the model and light 6 or 7 times the distance the light is to the model, we should only have around 2 to 3% of the light hitting the wall. That should result in a near black, if not a perfect black background. Now, as a side note, if you are photographing a larger group of people, having the lights further away from the group will give you a nice even exposure, because if we follow the inverse square law, if the distance from the closest person to the furthest person is quite small in relation to the distance the light is placed, the light fall off will be almost unnoticeable. I want to leave you with one final example of how the inverse square law can be used creatively. This photo was taken in a daylight lit room. By placing a speed light just out of frame and extremely close to the hand, you can see how quickly the light falls off along the neck of the guitar, resulting in the entire room showing up perfectly black. The inverse square law works exactly the same regardless if the light source is a window, a reflector, a diffuser, a strobe, or a constant light. This is also why fashion photographers use large reflectors on their studio lights and place them 2 to 3 meters away from the model. It gives the model full freedom of movement without affecting exposure. Hopefully this video made sense of what the inverse square law is. I know that there is a lot to take in, so it might be worth watching the video again if any of it didn't quite make sense. Thanks for watching this TechCorner video. Please comment below with any questions and don't forget to subscribe and press the bell icon so you don't miss out on our future videos.